screen, you're going to see a drawing of me telling you everything you need to know about an ellipse. I used to have a different little screenshot here, and I swapped it out with my own drawing because I think I know more than what the screenshots could find for me. Just talking about definition of an ellipse first. We can see an ellipse is cut from a cone, like the intersection of a plane and a cone. It creates this kind of elongated circle shape, kind of maybe like an egg shape or a football shape. Here's its technical definition. An ellipse is the set of all points on a plane whose distance from two fixed points, those two fixed points are called the foci, add up to a constant. Foci is plural of the word focus. Yep. So two fixed points add up to a constant. I have this video of this math dude showing you how to draw a perfect ellipse. I'll show you. So what he does is he puts these two pins down on a paper, and those two pins are the foci, or the two focuses.
The pins are located at the focal points of the ellipse.
Okay, and then to draw a perfect ellipse, you would have to attach strings to the focus.
At one end of the major axis with the string.
You'll swing it around.
In contact with the paper, draw the elliptical curve. This is a very smooth way of drawing an ellipse.
No, but that's how you would draw a perfect one.
The string is the length of the major axis.
Okay, so the distance on these two strings right here, no matter where you swing that string around, that distance always adds up to the same number. That's why on your notes it says it adds up to a constant. So no matter where you swing around that string, it's going to add up to the same number here. Now obviously I'm not going to pass out string and push pins and get us all to draw perfect ellipses. So what we do instead is I usually just draw it regular, my best egg shape I can, and then I put in the little foci after the fact. I just include them after the fact to make sure I have it technically perfect. We can see our two equations of ellipses in the middle here. We kind of looked just a little bit yesterday at what an ellipse equation looks like when we were putting them in their standard form. So ellipses are either going to face horizontally or they're going to face vertically. Now the equations are kind of the same whether they face horizontal or vertical, and how I tell the difference between the two, horizontal, you're going to have a bigger denominator under the x term. If it's vertical, your bigger denominator is going to be under the y term. So wherever your bigger number is, if it's under x, it's going to be longer in the x direction, making it horizontal. If the bigger number is under y, it's going to be longer in the y direction, making it vertical. To find where on a ellipse there's vertices, which is plural of vertex, and there's also co-vertices. Co-vertices is basically the ends of the shorter axis. And then we also have center, we have our two foci. So how I do that is I start by plotting my center, and then underneath the x term is a squared. So I would count a units in the x direction, which is like left and right, and those help me find my vertices. And then underneath the y term is my b squared term, so I'll count b units in the y direction, which is up and down, to find the co-vertices. And same thing for this one, just whatever number is under x. If that's b squared, you'll count b units in the x direction. Underneath a squared, you'll count a units in the y direction. It'll make more sense once we do one. Everyone chill. And then after the fact, I'll put in my foci afterwards. Let's try one. We're going to jump right in. This one is in its standard form already, so we don't have to complete the square or anything. So first thing I'm trying to figure out is whether it faces horizontal or vertical, and that's based on my bigger denominator. My bigger denominator is under x, which means it's going to be longer in the x direction, making it horizontal. Good job. Okay, my center is still at HK, just like we had yesterday. H is always paired with the x term, K is paired with the y term. And just like yesterday, we want to write down opposite signs with those. So my center would be at 2, -3. Very good. I'm going to go to my graph and go ahead and plot that center at 2, -3. 2, 3, 1, 2, 3. I'm just going to label it with a little C for center so I remember. Okay, now I'm going to use these two denominators here. Okay, so both of these are already squared. Whenever we use them, we want to use their square root. So square root of 16 would be 4. So that means I need to count from the center 4 in the x direction. 4 in the x direction, which would be left and right from the center. So from my center, I'm going to count 4 left and 4 right, because that square root of 16 was under x. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Underneath the y term is a 4, but remember this is already squared, so we want to use its square root, which would be 2. So we'll count 2 in the y direction from the center. 2 in the y direction from the center would be 2 up and 2 down. Okay. So the vertices are going to be the ends of the longer axis, which for this one would be the ends of the x-axis, basically. So this would be one vertex, this would be another vertex. The co-vertices are the ends of the shorter axis, which for this one would be the vertical axis. So here's one co-vertice, here's another co-vertice. If you want to, you can draw your best egg shape now. Give it your best. Just try not to make it have right angles, obviously. Yeah, it should be kind of football-y. Okay, so we can write down the endpoints of our vertices and co-vertices now. Let's see, I had one vertex at -2, -3. The vertex on the right, 1, 2, 3, 4, 5, 6, 6, -3. Okay, my co-vertices again were the ends of that shorter axis. So I have one at 2, -1. I have the other one at 2, -1, 2, 3, 4, 5. Okay. And then last thing we're going to do is draw in our foci, because the foci are the technical definition of how to draw an ellipse. So even though we kind of free-handed it and didn't use the foci to draw it, we do need to include them after the fact. So foci, if you look at my little note here, they're C units from the center on the larger axis. And in order to find C, we have to do a squared minus b squared. So c squared is going to be our a squared minus our b squared, which are basically our two denominators, here and here. We just want to make sure we subtract them in the order that we get a positive number. So is that going to be 16 minus 4 or 4 minus 16? 16 minus 4. So c squared equals 16 minus 4, which would be 12. So c is going to be the square root of 12, which actually does simplify. 12 has a perfect square factor, 3 and 4. So we'll take out the square root of 4 and we'll... Very good. All right. We do probably also want to approximate how much the square root of 12 would be, kind of as a decimal, just to give us a better idea of where it's going to be on the graph. The square root of 12, I know square root of 16 is 4, and square root of 9 is 3, so it's in between 3 and 4. I'm going to call that 3.5 or so. So my two foci should be on the longer axis, C units away from the center, and we know C is about 3.5. So 3.5 from the center, left and right. So from the center, we'll go 3.5 to the right. So there's one. We'll go 3.5 to the left. There's the other one. Now when I write their ordered pairs, here's the tricky part. Both of these ordered pairs for the foci, they have the same y value. What is their y value? -3. So I'm going to set that up first. I know the y value is -3 because they're both down 3. Now to find the center, we don't want to do the decimal approximation. We use the decimal approximation to help us graph it, but we want to use this exact number. So we were at the center. What is the x value of this center? 2. So we were at 2, and we went to the right 2 root 3, and we went to the left 2 root 3. So we were at 2, and we added 2 root 3. And then for the next one, we are at 2, and we subtracted 2 root 3. Those are its exact foci numbers. Yep. It's not that bad. You survived. All right, let's look at the next one. The next one is actually not in perfect standard form yet, because if we remember, standard form for an ellipse has little fractions here. There's just one tiny last thing we have to do. Very good. We'll need to divide every term by 225. Basically, they already completed this square. They just didn't do that one last step that we can do. So on the first fraction, 2 over 225 does reduce, because 225 is divisible by 25. It's 9. Okay. And then for the second one, 225 is divisible by 9. What's 225 divided by 9? 25. And then on the right side, what does that simplify to? No, well, 1. So if I clean that up, I'll have x plus 4 squared over 9 plus y minus 2 squared over 25 equals 1. Okay, now remember, to figure out whether it's horizontal or vertical, we're looking at which term has the larger denominator. Does the x term or the y term? The y term has the larger denominator. That means it's going to be longer in the y direction, meaning that it's going to face vertical if it's longer in the y direction. Vertical. Okay, our center is still at HK. You can see the H here, the K here. We just need to make sure we write them with opposite signs. What would my center be at? -4, 2. Very good. Okay. I'm going to go ahead and graph that center on my graph at -4, positive 2. And there it is. I'll label it with a C for center. Okay. Now to find my vertices and my co-vertices, remember I'm going to use my 2 denominators, but the denominators are already squared, so we just want to make sure we use their square roots. So the square root of the 9 would be 3, so that means we need to count 3, bless you, 3 in the x direction because it's under x. So from the center we'll count 3 right and 3 left, 3 in the x direction. 1, 2, 3, 1, 2, 3. Okay. Underneath the y term is 25, so we're going to use its square root, which is 5, and we'll count 5 from the center in the y direction. 5 in the y direction. So from the center, that means we need to go 5 up and 5 down. Now labeling which ones are the vertices and which ones are the co-vertices. Remember, the vertices are always going to be the ends of the longer axis, which for this one is the vertical axis. The co-vertices are the ends of the shorter axis, called the minor axis, which for this one is the horizontal one. And then from there you can give it your best football shape to the best of your... I have to turn my paper. It's really hard for me to... Okay, alright, that's not bad, not bad. Okay, I'm going to label what my vertices were at. Remember, vertices are the ends of my major, longer axis for this one. So one's going to be at -4, -1, 2, 3. The one up top is at -4, 2, 3, 4, 5, 6, 7, -4, 7. Okay, my co-vertices are going to be the ends of my shorter, my minor axis for this one. So I have one at -1, 2. And then another at -4, 5, 6, 7, -7, 2. What y'all got? Okay, and then last up, we're going to put in our foci, which are part of the technical definition of how you would draw an ellipse. Even though we kind of free-handed it without, we can still put them in after the fact. Remember, foci are C units from the center on the longer axis. C is found by doing your a squared minus your b squared, which is your larger denominator minus your smaller denominator. C squared equals a squared minus b squared. So we'll take our larger denominator of 25, we'll subtract our smaller of 9. What do those subtract to?
16.
Hallelujah, a perfect square. 4. So those two foci should be on my longer axis, C units from the center. So for us, that would be 4 units from the center on this one. So from the center, we need to go 4 up and 4 down to put our foci. There's one. There's the other. Those are much easier to write the ordered pairs for because they are nice, pretty numbers. One of them is going to be at -4, -2. And the other is at -4, 1, 2, 3, 4, 5, 6. You didn't? I already knew that. Questions so far? Are you following along? Alright, for the next one, we're going to need to practice our completing the square, just like we learned yesterday. What was our first step for completing the square? Yes, group similar terms together. Now, if you notice, there are 2 square terms, but this first one doesn't have like a similar term. You might have experienced this on the homework. That just means you have to complete the square fewer times. You won't have to complete the square for both the x and the y. You'll only have to do it for the y. So I'm going to rearrange. Let's see, 2x squared. Actually, it's already grouped pretty nicely. Plus y squared minus 4x. I will have to complete the square for the y, so I'm going to leave a blank for that. And I'm going to take that -6 and add it so it's on the other side. And then I'm going to leave a blank on the right to remember to complete my square over there. Oh, sorry, I wrote x instead of... Oh, thank you. All right, erase. I grouped the x. I thought it was a y. It was not. Okay, trying again. 2x squared minus 4x plus blank. And now the y is the one that doesn't have the matching pair. Thank you for noticing that. My brain just was like, no, letters don't exist. And then on the right-hand side, I'll have that 6 and my blank again. Okay, now I know the x's are in a group together. Anyone remember what we're going to need to do first, though?
Cn, or sorry, x. No, divide the b. Divide the b.
Not divide the b.
You have to find the GCF.
Take out the leading coefficient, yes.
There's going to be 2.
Mm-hmm.
X squared plus or minus 2x plus, we don't know. See, I was right.
You were right, yep.
I just didn't know what to say.
Now we can do what Mason was saying. We have to do our b over 2 squared. So that would be -2 over 2 squared, which is -1 squared, which is 1. But is 1 what we add to the right?
Yes.
No.
2 times the 1.
We do 2 times the 1, right. Okay, so this x term should be a perfect square now, so we should be able to factor it as just one factor, one identical factor squared. What is that one identical factor? X minus 1. Very good. We'll bring down our y squared. On the right, we'll simplify and get 8. Okay, and then there's one last step to get it in perfect standard form, because remember, an ellipse always has equal to 1 on the right-hand side. Divided by 8. Very good. Bless you. So this first fraction will simplify. So we'll get x minus 1 squared over 4. Plus the second one does not simplify. It's just y squared over 8 equals 1. There is our beautiful standard form that we're going to find all of our information from. Remember, to figure out whether it's horizontal or vertical, we're looking at those two denominators. the larger denominator is underneath the y variable, so it's going to be longer in the y direction, making it a vertical ellipse. My center is at HK. If I don't see my K number, what is it?
1.
No,
0.
it's a 0. Because technically it would be y minus 0 squared. So my center is going to be at 1, 0. Very good. I'm going to go over to my graph and graph that center at 1, 0. To find my vertices and co-vertices, I'm going to use these two denominators. Now both of these are already squared. Okay. So starting with the square root of 4, that would be a 2. So from the center, we'll need to count 2 in the x direction. So that would be 2 right and 2 to the left.
And then we do the same thing for the 8.
Yes, but what's wrong with the 8?
There's no square root.
There's no square root of 8.
It's such a perfect number to have square root.
Square root of 8, that's square root of 4 times 2.
And then you put out the 2, so it's going to be 2 square root 2.
Okay. We do need a decimal approximate, though, to put it on a graph.
So then you do
2.8. Yeah, because square root of 9 would be exactly 3, so square root of 8 is less than that. We'll call that 2.8, I guess. Okay, so that means we need to count from the center 2.8-ish in the y direction. So that's 2.8-ish up, 2.8-ish down. 2.8. 1, 2.8. And then remember, the vertices are the ends of the longer axis, the major axis. The co-vertices are the ends of the shorter axis, which is the minor axis. Give it your best egg shape that you can. We're egg shaping, Lydia?
Yes.
Yes, we are. Wow, beautiful. All right, vertices are the ones that are going to be kind of annoying to write because they had a 2 root 2 in them. But both of them have the same x or the same y? They have the same x. What is their x? No, their x is 1. So I'm going to set up my 2 points. I know both of them have an x of 1. Okay, now thinking about what the y value is. We were at a y of 0, and we went up 2 root 2, and we went down 2 root 2. So one of them is going to be 0 plus 2 root 2, which is just 2 root 2. And the other one's going to be 0 minus 2 root 2, which is negative 2 root 2. Co-vertices are a lot easier to write because they are whole numbers. One's at negative 1, 0.
Wait, what's the vertices?
The vertices is the what? Ends of the longer axis.
So like the top and the bottom.
Mm-hmm.
It's longer on the top. Since it's longer, it's
You have a stink face on her.
oh, like, is it
1, 2, 3. 3, 0 is the other one. And then last thing we need to do is put in those technical foci. Even though we were able to freehand it without, they are part of the definition. How do we find them again? Yes, we got to do our c squared equals our a squared minus our b squared, which is our larger denominator minus our smaller denominator. Okay, so that means the focal length, the distance between the center and the foci is 2. So from this center, the foci should be on the longer axis, 2 units up and 2 units down from the center. 2 up, there's 1, and 2 down. There's the other. Those also should be easy to write the ordered pairs for, because they should be at whole numbers, integers. Let's see, we'll have 1, 2, and the other one is at 1, comma, negative 2. Very good. All right, for the very last one, we're going to go backwards. We have information about the ellipse. Our job is to write the equation. Okay. Starting with, it says it has vertices at negative 3, 4, and 5, 4. So I'm going to plot those. Negative 3, 1, 2, 3, 4. There's 1. And foci at 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. We're also told it has foci at negative 1, 4. 1, 2, 3, 4. And 3, 4. 1, 2, 3. Oh, you're back. Okay. So I'm going to set up just kind of a blank ellipse equation in standard form. Aside conversations need to stop. Okay. Blank ellipse equation. I know there's going to be a fraction plus another fraction. What's it going to be equal to? 1. Very good, because if we think about standard form, they're always equal to 1 on an ellipse. There's going to be some sort of numerator squared. There's going to be some sort of numerator squared on the second one. So starting with thinking about where the center is. Actually, let's think about just which way it faces. If the foci and the vertices are on this horizontal line, which way is it going to face? Yeah, it should face horizontal. Faces horizontal. Okay, if it faces horizontal, my larger denominator should be what? Under x or under y? Yeah, the bigger number should be under x. Bigger number should be under x. Can we see where the center is? Yeah, the center is actually just the midpoint in between the two foci, or the midpoint in between the two vertices. It doesn't matter. So if this is negative 1 and this is 3, you would add those up to get 2, and then you would divide by 2. What's 2 divided by 2? 1. So the midpoint should be at 1, which you could kind of visualize as well. So I'm going to write down that center. It is at 1, 4. How's that going to help me write my equation? Yes, that's my h and k. Good job, Sean. So on my first numerator, I'll have x minus 1. On my second, I'll have y minus 4. Now figuring out those two denominators. The denominator that was under x, we can actually see how much we counted in the x direction. Okay? To get from the center to the vertex, we counted 1, 2, 3, 4. So the number under x should be 16, yes. Now to find the number under y, we can't actually see that. So what we're going to have to do instead is we're going to have to use our c squared equals a squared minus b squared. Because I can find c. C is the distance from the center to the focus. So c is 2. Let's see. So 2 squared equals... Is this for the A or the B? If it's longer in the x direction, yes, the 16 should be our A squared. Alright, we're going to solve this little equation. So that gives me 4 equals 16 minus b squared. So negative 12 equals negative b squared, which means b squared equals 12. In order to write my denominator, do I have to put a 12 here, or would I have to put the square root of 12 here? Maybe you just need a 12 there, yeah. Yes, your co-vertices would be square root of 12 up and down from the center. Square root of 12 is about how much? Okay.
No, I was doing this a little bit before you were on it.
Oh, you were?
I did like the entire thing, and then the only thing I did wrong is that I thought it was
Oh, you did?
But that actually doesn't really matter because I can just change it. Because I put 20 for the denominator of the second one, and I can just change it. It was perfect.
Nice.
So like, it's an easy problem.
Yeah, it's kind of just like a little puzzle you have to put together.